Now I am going to consider the quadratic polynomial having exactly one zero. I mean one real zero. Again the same doubt as earlier you might have got in your mind that quadratic polynomial has two zeros. Now I said that there is only one real zero. Then what about the other zero? Who can discuss here? Of course, certainly it has two zeros, but it repeats twice. Only one zero repeats twice. Such a situation I am going to consider here. That is a quadratic polynomial with exactly one real zero. Now you can see here, consider the quadratic polynomial y is equal to px is equal to x square minus 2x plus 1, and let me call it as y, and corresponding to x and y, look at the table here. X is equal to minus 1 and y is going to be 4, 0 and 1 and 1 and 0, 2 and 1, 3 and 1, 3 and 4. Corresponding to these values, first let me consider the coordinate axis here. Now I am going to plot the points here according to the values given in the table. Minus 1 and 4, minus 1 and 4, and 0 and 1, y x is equal to 0 and 1 here, that is 0 and y is equal to 1, and 1 and 0, now here 1 and 0, that is the point 1 and 0, and next 2 and x is equal to 2 and y is equal to 1, that is here x is equal to 2 and y is equal to 1, and 3 and 4, 3 and 4 here, here 3 and 4. Now according to the points I am going to join by a curve. Now you can see now it touches only in what you can say, the curve that is the px touches x-axis at 1 and 0, and therefore 1 is a 0 of the polynomial px is equal to x square minus 2x plus 1. As I have told, any quadratic polynomial has exactly two zeros. Then what about the other zero? But here there is no other zero other than 1, but no other zero, but 1 repeats twice here. Because you can see here, because px is equal to x square minus 2x plus 1, that can be written as x minus 1 whole square, and therefore 1 repeats twice. Now we can consider another example of the same kind. Consider B, that is a px is equal to minus x square 2x plus 2x minus 1. Now we can see the table accordingly here. With this 0, minus 1 and minus 4, 1 and 0, and here also you can consider the coordinate axis to the right side here. Accordingly, I would like to plot the point here 0, x is equal to 0, y is equal to minus 1 here, and x is equal to minus 1 and y is equal to minus 4 point here, minus 1 and minus 4, and this is what can say 0 and minus 1, and another 1 and 0, 1 and 0 point here, 1 and 0, I can write down 1 and 0, and 2 and minus 1, 2 and minus 1 here, 2 and minus 1, and 3 and minus 4, 3 and minus 4. So, as in the earlier case, you can join the points by a suitable curve, and that curve open up below here. From these two examples, what you can conclude here, look at the first one, px is equal to, I can write down 1 into x square. For the sake of convenience, I am going to write down minus 2 into x plus 1. And the second one, px is equal to minus 1 into x square plus 2x plus of minus 1. Look at this. This is 1 is a positive and here minus 1 is a negative, and here 1 is a positive, so the curve, parabola opens up above, and this second case minus 1, the curve opens below, and because of this quantity, in general, for any quadratic polynomial, px is equal to ax square plus bx plus c. If a is greater than 0, I mean positive, then it opens up above. And if a is a negative, then it opens below. And this is the idea where we can get the curve, and this will give the nature of the parabola, what type of parabola, whether it opens up above or it opens up below. This is the idea behind these two examples.